So good day guys, welcome to today's video. In today's lesson we are going to be talking about the analysis. So since we've checked the model, the next thing we can do is to run the analysis. So you can see it here. If you don't see it here, you can press F5 on your keyboard, or you come here, this is the shortcut, and run the analysis. So that is after correcting all your modeling errors like overlapping slab, overlapping beams, which we'll do in future video. So now by the left hand side it is running the analysis. So it's going to take a little while because first the meshes are very small and this is a big building, so it has a lot of matrices to run. Okay, so let's run our analysis. So it is almost done. It has done the first phase of the analysis. Now it is running it now. So we are done with the analysis. So this is, that's been decomposed, that's been discretized. That's why this slab is like this. And the advantage of ETABS over STAD is, on STAD, once you measure slab, each beam will be broken, but the beams will still remain one. So you can easily edit and correct whatever you've done. Okay. So now what we need to do first is to see our slab deflection. So let's go, since the slabs are typical, let's just pick a typical slab. Let's say the 15th floor. Okay, now we have this. Now the code, Eurocode says to check your slab deflection, you can use the live load, a load which is span, the short span over 360. But in this case we want to play safe, so we use the dead and the live together to check it. So me, generally I make sure my deflection does not exceed 20 millimeters generally for myself. So I'll come to the combo I created, dead plus live, select it. Now I need it to draw contour on the object and then use Z, so that is the displacement in the Z direction. So put it there, click apply and say okay. So we can now look at our contour and let's see if the slabs are sufficient. So generally at this point, for dead and live, I have a displacement of 21 at the middle, so I can still permit it. It's still within tolerable limit because this is dead and live. But the code has said I should use live, so if I use live alone it will be less than that. So let's go back here and choose live load alone. Okay, so I have a live load and the maximum is just 4 millimeter in the middle. So once you put your cursor on it, put your cursor at the joint, you can see it's 4.2 at this point. So it is very okay. So but most times in the industry everybody wants to play safe, so we just use dead and live. Okay, so we've done that. So the reason why I'm saying you should use live alone is because live is variable. Is when people are working on it that they notice the deflection, not that when it is there. That is what the code is assuming. So but in previous code it used to be dead and live alone, but till now we still use dead and live. Some people in the industry, what the code permits you to use this. So we are done with this. Now the next thing I want to do is to check my um so my story sway and story drift, so I can turn this off to just come here and put it to non-deform shape. So let's go to where we have, so let's come to display. Then you can see story response plots. Okay, so select it now you can see this graph, right? We can see this graph. So the red is for the global Y and the blue is for the global X. Okay, so now what we're interested in doing is to check the lateral load. And like I said in all my videos or codes, that for every story the maximum uh, displacement you should have is h over 500, and now we know our h is 49,000 millimeters. So the maximum displacement you should have, maximum story displacement under any load case or combination in the service should be h over 500. Once it's exceeding h over 500, which is 49,000 divided by 500, which is going to be about 98. Once it is exceeding it, then you have to either change your column size, make the building more stiffer, because the stiffer your building, the less it deflects, and the more flexible your building is, the more it deflects. So the ball is in your court. So what we'll do is we'll come here and let's check dead plus live first. Let's see it. So we can see our displacement under dead plus live in the global y direction. It is just about, once you put your mouse at this tip, look down here, you will see it. So put your mouse at the tip, you can see it. It is 2.56 millimeter. Okay, then minimum 0 at the ground floor. Okay, then the next one we need to do is dead plus live plus EQX. So select it and let's look at it. So now we can see on the EQX we have exceeding 161 millimeter. Then on this we can use another one to see our X. So in the EQY, the reason why it's EQY is because EQY is stiffer. If you look at the EQY, sorry, let's come back to the plan. Let me see if I can come to the plan from here. Sorry, plan. Let me pick one particular flow. So this is the EQY. We can see the EQY. Now before we go back to this again, let's check our forces. So let's go to 3D. Let's see our forces. So come to display, load diagram, and let's check our frame load. We know our frame load is the block or load on those blocks. So we'll come here to dead and sorry, let me check live. Okay, sorry, it's not going to show. Let me come to display and check joints. So what I want to check in my joints is just my WX. So apply. So that is the wind in the X direction. So the reason why there's no wind at this top is because there's no slab to act as a diaphragm, so it's not going to do anything. But another way is coming here, you can see this, see it, so you can see the way it is. Okay, so this is the wind in the X direction. Now let's check the wind in the Y direction. Select it, apply. So like I said, like I told us, that the way it is going to behave is the total load, the windward plus leeward, will be added together. But normally you can decide to add windward here and leeward at this point. So you can see our wind here. Next thing I want to do is to check my EQX. So nothing is there. So EQX 1/3, because we selected three things there plus eccentricity, and we can see this. It's going to be a little bit bulky, so you can see the way the earthquake is moving. Okay, so we can check all other things here. So let's go back to the frame and okay, so go to display and let's go back to load assign frame, and let me check the block wall. I think the block wall is under super dead, so it takes a little while for this to go off, and let's change this. So super dead, apply, and so you can see the block wall load. Now if you are using membrane, you can come to shell and to show you that tributary area on it, so you can come here, but since we are not using membrane, it won't do that for us. So let's come to live load, gravity. Okay, apply. Sorry, let me use this here. So it's not really going to show because we are not using what we call the tributary area. That's why it won't show. But for that, we are done with that. So let me and let's go back to the story response plot. Okay, so let's go back to the story response plot. This is dead plus life plus EQ. This is dead plus life plus WX. So with wind, we are okay with wind 84, which is less than that there. Coming back to this, we are also okay in the y direction. So let's assume we are only doing wind load, then we don't need to place shear wall because what we have here is within the h over 500. So it's just that when we have this in our EQY, because that place is slender, so we need to place walls to stiffen that place. Then we need to do that. Now we are done with the maximum story drift. Let's go to maximum story drifts now. So we'll do the same thing there, and we can see that we have a maximum story drift, dead, live, and EQ around this place, but the something must not be more than 0.04. That is 1 over 25. It must not be more than 8. So our drift is okay with this. Let's see the other direction. Our drift is also okay. So let's see it for the wind. Okay, so our wind to is 0. So it's okay with that. So the only problem we are having is this is the only problem where we are having this, sorry, maximum displacement. So this is what we are having. So it's indirectly telling you that people will not feel comfortable because the y direction, the x direction is slender, so you can see it. So the only two things we can do here is, one, if we want to use first order analysis like this, we have to place a shear wall, a bracing element, which will take the sway, which will take the displacement rather, or we can decide to do second order, which is P delta, and will create a moment amplification factor. But that will be another video in future. But for this video, we'll be putting the shear wall. So let's create a shear wall and let's see the effects of it, how it will reduce it in the next video.